Hello, everybody. Mr. Raz here, getting ready to give you another note party. Note party. All right, so um, we're finishing up this section of 10.4, and this final part of this section is the area of a segment of a circle. All right, so what a segment of a circle is, it is a part of the circle that is bounded by an arc. All right, so let's think about this. Bounded by an arc. So here is an arc and the segment joining its endpoints. So A and B are the endpoints of that arc, right? A and B are the endpoints of that arc, and the segment that joins those endpoints. The area that is bounded by that region is called a segment of the circle. That is the segment of the circle. And what we're going to do today is we are going to find the area of that part. All right. All right. Let's look at how we're going to do this. Okay. So the idea is we're going to first find the area of the sector. Now remember what that was. That's what we just finished, finding the area of the sector. That was this part, right? So here's the area of the sector. The sector was the area bounded by two radii and the arc. So that was the sector. Our plan is to then, we'll find that area. We're going to subtract the area of the triangle. That's what this green part is in the second part, right? This green part here. This is the triangle. And if I take this triangle away from the sector, I'm subtracting it away from the sector, I'll be left with the segment. That's this blue part. Okay, I'll be left with the blue part. So that is the goal. So here we go. The formula we're going to use is this. The area of the sector, that was this part. That's this formula. It's the formula we just finished. It's the measure of the arc in degrees over 360 times pi r squared. That gave us the area of the sector. Now we're going to subtract the area of the triangle. And in a circle, a triangle that is formed with two sides being the radius, the area of that circle is 1/2 r squared, r being the radius, sine of theta. All right. Now, think about this. This was the arc in degrees. Right. The r stood for the radius of the circle. So that takes care of that part. We're going to subtract 1/2 r squared. Again, r representing the radius. And now theta represents the central angle. So this particular formula that we're going to use to find the area of the segment, it's a pretty simple formula, and you really all you have to do is just plug in numbers and use the calculator. All right. All right, let's give it a try. So find the area of the shaded segment. So the goal is to find the area of the blue part. All right. So my first thought, I'm going to find this entire sector. Okay, I'm going to find the entire sector. That formula is the measure of the arc over 360 times pi r squared. That'll give me this entire area. Okay, then I'm going to subtract the area of this triangle. And when I subtract the area of that triangle, which that formula that I'm going to use is 1/2 r squared sine of theta. So when I subtract that, look what happens when I subtract that. I'm going to erase it and notice what's left. The area of the segment. All right, let's plug in what we know. So the measure of the arc, the measure of this arc, the measure of this arc, well, it was there, but I erased it. This was 90 degrees. So we have 90 over 360 times pi, and then my radius, which in this example is 8 squared. Now, if you want, I would work on this part first. Okay. Now, because this part right here, the 1/2 r squared sine theta will more than likely be a decimal, I'm going to actually turn this entire problem into a decimal. I am not going to leave it in terms of pi. I'm just going to put it in, plug 3.14 in for pi and get an actual decimal. All right, so I'm going to take this part right here, 90 over 360 times pi r squared. Go into the calculator. Here we go. All right, 90 divided by 360. All right, gives me 0.25. 0.25 times 3.14 for pi. That gives me 0.785. 0.785 times 8 squared. And there's my answer, 50.24. 50.24. So this part right here is 50.24 minus, now I'll do this one, 1/2 8 squared sine, and because this central angle was 90 degrees, sine of 90. Okay, I'm going to go over to the calculator and do this. All right, clear all. 1 divided by 2 gives me 0.5. 0.5 times 8 squared gives me 32. And 32 times sine of 90. Hit enter and boom, 32. So this part is 32. Okay, all I have to do is 50.24 minus the 50.24 minus the 32. 50.24 minus the 32, and I'm left with 18.24. So the area of just this segment in this problem, just this segment, is 80.24, and area is always units squared, so centimeters squared. All right, let's try one more. Okay, here we go. The formula, the measure of the arc over 360 times pi r squared minus the area of the triangle, 1/2 r squared sine of theta. Okay, so there's the formula. The only things that I need to really plug in, right? What do I have to plug in? I have to plug in this, 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 and this. Those are the only things that I have to plug in, and then it's a matter of just plugging in the calculator and evaluating. All right. All right, so what is the measure of the arc? What is the measure of this arc in degrees? Okay, that's good. Since my central angle is 120, this is 120. So 120 divided by 360 times pi. And what is my radius in this problem? My radius is 3. Okay, I like to stop right here and just evaluate this in the calculator. I'm going to plug it just like that in the calculator. All right. So 120 divided by 360, enter, gives me that. So 0.333333333 times 3.14, enter, gives me that. 1.0466666666 times 3 squared, 9.42. So this first part is 9.42. Now I'm going to subtract this part. So let me fill in what I know. 1/2. I already know that the radius is 3, so 3 squared times sine of theta, and theta is 120. Okay. Again, straight calculator. So 120, let me clear all. 120 divided by 360, enter. Oh, I'm sorry. Let me go back. So it's just 1/2 3 squared sine of 120. That's what I'm trying to do. So 1 divided by 2, enter, 0.5. 0.5 times 3 squared. That's 4.5. And 4.5 times sine of 120. And I get 3.897. So this part right here is 3.897. All right, and all I have to do is subtract that. So 9.42 minus 3.897, 5.523. And there's the area of that segment. All right. Again, that was the last set of notes for 10.4. Tomorrow, I'm going to do a video on 3 practice problems. So I'll show you a problem. I'll work one out. Then the second one, you'll have the opportunity to pause, work it out, then hit play and check your answer. And then that'll be it for this week. Next week, we'll have to come up with some sort of quiz on these 2 sections. All right. Hope everybody is doing well. Have a great day.